All right, so for this video, we're going to be talking about the graphs of sine and cosine. So we're going to be talking about a section of key features over the next couple lessons. So today we're going to talk about midline, amplitude, and maximum minimum. So the graphs of sine and cosine are actually from the unit circle, and I know that you haven't done an in-depth look at the unit circle. However, we still are going to look at the key features and how graphs of sine and cosine look on a coordinate plane. So we have our basic sine graph where we have y equals a times sine of bx plus or minus c plus or minus d, and y equals a times cosine bx plus or minus c plus or minus d. And we're going to talk about what that a, b, and c, and d, how those all affect the graph. So first thing I want to look at is I want to look at Desmos, and there's a reason I want to do that. Because there's a difference between how you graph when it's in degree mode and then when it's in radian mode. And so if I come here and I do y equals the sine of x. So right now under my settings, I'm in degree mode. And I don't see a whole lot. I should see something that looks like a wave, okay? And that wave graph I'm not seeing here. And there's a reason for that. Because in a circle, a full circle has 360 degrees. So your degree measurement is on your x-axis. So right now I'm only going to see negative 10 degrees and positive 10 degrees. So what I'm going to do here is I'm going to go under settings and I'm going to adjust my x-axis. And I'm going to change that to negative 360 and positive 360. And I can now see that wave start to happen. But because we were only 10 units of 10 on each side, we couldn't see that before. And that will drastically change if I put it into radian mode, because radians is measured based off of the length of the outside of the circle. It's based off of the circumference. So if I hit the home button, if I'm in radians, I can actually see the wavelength much easier because I'm not actually looking at such a large number. However, if you're looking at radians, you're going to have to know what pi divided by 2 is. You're going to have to actually divide out pi divided by 2 to get, oh, well, this right here is going to be 1.57 is my actual x value. So just keep that in mind. There's different ways of looking at it. So we're going to come back to that in a minute. But for what we're going to look at, we're going to start with the amplitude. So the amplitude is half of the height of a wave. So when I talk about a wave, we are actually going to talk about from where one top of a wave goes to the very bottom of that wave. Okay, so I'm going to start at 0. So the reason I'm going to start at 0 is because that's where most of your graphs are going to start. And I'm going to start with the sine graph. So the sine graph is in green. So if I am talking about a wave here, I'm starting from my top of my wave down to my bottom of my wave, okay? So that amplitude that they are discussing in that problem is actually going to be the distance, that half distance, okay? And that half distance is going to be represented by what they call the midline. So the midline is the line that actually splits your wave in half, okay? So your midline is going to split your wave in half, and it's always going to be a horizontal line, and it's always going to be y equals in a value. So this one is actually y equals 0 because it's splitting it at the value of 0. We also have maximum and minimum. So this one has a maximum value. It goes no higher than 1. This one has a minimum value that goes no lower than negative 1. So those are the three topics that we're going to be talking about today. So amplitude is half the length. So the amplitude for this particular problem is 1 unit, okay, because we're going from 1 to 0. And then we're going to talk about the midline, which is going to split your waves in half. And then we're going to talk about the maximum and the minimum. So when we talk about amplitude, I'm actually going to look at a couple of equations, and we're going to look at how to actually identify it using your equation. So I have two equations here, and we're going to kind of compare them and see what we can say about both of them. So for the first one, I have y equals 2 sine of x. All right, so we are in radian mode right now, so we're just going to keep it in radian, and so we can see everything that we're talking about. So if I talk about my amplitude, I'm talking about the distance from the x-axis up to the top of the actual maximum, the heel of the wave. So I'm going from 0 to 1, okay? So that amplitude for this particular problem is at 1. So now if I do y equals, this one said -2 cosine of x. And then what do I notice about this problem? Well, again, I have negative cosine of 2. Regardless of whether it was positive or negative, they both have an amplitude of 2 because it's half of the wavelength. So when we talk about amplitude and we talk about the equation, your amplitude will always be the absolute value of the A. So the A is that number in front of your sine or cosine. So when I looked at the 2 cosine of theta, I had, all right, so I'm going to turn this one off. So I started at 0, went up to 2, back down to 0, went down to -2, and back to 0. So this was my sine graph. So again, my amplitude is a distance of 2. All right, so the same thing happened with the cosine. So I'm going to go back and look at this one and turn that one off. So I started at 0 at -2. All right, and then when I started at -2, I started to go up, and I hit at 0, went up to +2, came back to 0, and then finally back down to -2. So we have a wave that looked like this one. But again, regardless, I still have an amplitude of 2. Even if I use this one down here, that's still going to be my distance from the midline to the top of the crest. This one also has a maximum value at 2 and a minimum value at -2. So let's just kind of look at some examples and let's identify these key features, okay? So for these next few problems, I have, it asks for the max value and the minimum value. So my maximum value is the y value that it hits the highest amount. So my max value is going to be 3. My minimum value is the lowest value that it hits, so that's going to be -3, or excuse me, -5. Now my amplitude. It's easier to figure out the amplitude if you're thinking about the distance from top to bottom. So if I'm talking about the distance from -3, or excuse me, -5 to +3, we're talking about units of 1, 2, 3. So we have 1 unit, 2 units, 3 units, 4 units, 5, 6, 7, 8. So 8 units. So if we're talking about it's 8 units tall, that means that we're going to have a midline at 4 units. So my midline is where it splits it in half. All right, so my midline is actually going to be the equation y equals -1 because it's crossing the y-axis at -1. So my amplitude is half that. So my amplitude is actually going to be 4 because it's going to be that distance from the midline to the top of one of the hills or to the bottom of one of the valleys in that wavelength. Okay. All right, so for this next one, you can see that it's kind of, this wavelength has shifted over. So it looks very similar. There are some unique changes to it. However, you can also still see that there are also going to be some similarities here. So we can still see that there's going to be a maximum value at +3, and there's going to be a minimum value at -3. So my midline, we still have, between the two, we're going to have 8 units. So from here to here, that's 8 units. So we're going to go to 4. So our midline is going to be, it's still going to be y equals -1. So therefore my amplitude is also going to be 4 units. The only difference here was that my pieces were actually scooted over. So like this one started and the wave kind of started and went up. This one was already up and started to go down. So could have been very different as far as it could have been a sine graph, a cosine graph, or it could have just been a sine graph that was translated left or right. So we just don't know at this point for those. All right, so for the next one, so our maximum value, we're going to have a maximum value at 2. We're going to have a minimum value at -4. So between the two of them, we actually have a total distance between the top of one hill to the bottom of that valley and that wave is going to be 1, 2, 3, 4, 5, 6 units here. So if we have 6 units, that means that my midline has to be halfway, which is going to be at 3 units. So my midline is at y equals -1. That is not always the case. We may have a midline depending on the equation. I'll kind of show you how to tell by the equation in the next few problems. So if my distance from wave crest to wave trough is 6, that means half of that is 3, so my amplitude is 3. All right, so my maximum here is going to be 4. My minimum here is -4. All right, so my amplitude, we're going to find the midline first. So that midline, if we count our units here, this is going to be 8. So 4 units to 4 units. That means that my midline is actually right on the x-axis, which is going to be y equals 0. So we're still going to have an amplitude of 4. Now, what happens if we're given the equation? So if we're given the equation, we can still find these pieces. And actually, it's a lot easier to find the midline based off the equation. And we can find the amplitude based off the equation. So remember, amplitude is the absolute value of A. So my A in this equation is 4. Now, my midline is always y equals the D value. So the D value is always that value at the very end, that plus or minus, that number, that constant. So I'm going to look at it in Desmos in just a second. But before we do that, I'm going to show you that this should be at y equals -1. And my amplitude is actually going to be 4. So let me actually go graph this and we will look at it. So we had y equals sine of 3x. And I need a 4 in front. So y equals sine of 3x. And we're going to do -1 at the bottom. All right, so again, we can see here that we have, so if I count my units, I have 3 units above the x-axis. And I'm actually going to take a screenshot so I can write on it. All right, so we have 3 units above. So we have, right here, we have a distance of 3 units. And we have a distance of 5 units. So if we do my midline at -1, like I said, that would split it in half. So again, I have a midline at -1, which we already determined. And my amplitude, if I have 8 and 8, is also going to be 4. And that was true. So now the difference is what is my maximum, what is my minimum. So my maximum here is going to be at 3. My minimum is going to be at -5. All right, so for this one, we have 3 was our maximum value, and our minimum was at -5. All right, so if I do that same pattern, our amplitude is going to be the absolute value of A, so that would actually be 1/3 this time. And our midline is going to be that absolute, or is going to be y equals D, so y equals 3. All right, so I'm going to go look at this in Desmos. And so I have 1/3 the cosine of x minus 1 got to get in the parentheses, and plus 3. So you can clearly see that we have a very stretched out sine, or we have a very stretched out wave right now. So if I look at this, I should be able to see, I'm going to kind of scrunch it together and zoom in so that it's a little bit easier to kind of see the spaces in between there. So we said that we have it at 3. So if you look at the midline here, all right, so I'm going to kind of plot some points and grab these points so we can see them. So we said the midline was at 3, which I think we all can agree that's going to split that in half. And we said the amplitude was 1/3. Well, if my midline is at 3, and then I am going up to 3.333, that means this is 1/3 because I'm adding 1/3 to 3. Or if I'm going down 1/3, I would be subtracting that, which would give me 2.66. So I still have an amplitude of 1/3. All right, so our maximum is going to be 3.33 if you want to round it, or we could do 3 1/3. And my minimum is going to be 2.66, or we could do 2 2/3. I'm okay with you rounding. The only thing is if you actually have to create equations later on, you're going to really want to use those exact values. All right, so we have 3.3 repeating, and we have 2.66 repeating. So therefore, my maximum value was at 3 1/3, and our minimum value was 2 2/3 because we were subtracting from that midline. And that should be negative. Actually, no, that's still going to be positive because I was thinking about it being at the negative value, but we were at 3. Okay, so that still would be positive 2 2/3. All right, so just to kind of refresh and make sure we're all on the same page here, my midline is going to split my waves in half. Okay, so you're always going to look for that equal distance above, so to the hill, to the trough, to the crest of the wave, and then to the trough going down. My amplitude is half the distance from the midline to the top of the crest, or from the midline to the bottom of the trough of the wave. And then my maximum value, my minimum value is how high does that wave go, or how low does that wave go.